Oh, hello. My name's Pete, and welcome to another session of Electronic Assisted Astronomy with an 8-inch Schmidt-Cassegrain telescope. In this case, a Celestron CPC-800, as you see here. It's out on the decking. I'm inside on the office. It's still quite cold out tonight, but I think it's like -4, -5. It feels like -4, -5 anyway. But it's out there now. If you want to see my setup, as in I discussed the kind of telescope, the computing and the software, then look at my previous video because that's got my EA setup in it. But this is the telescope we're using tonight. So what I've just done is I've just completed a focusing using SharpCap's FWHL multi, was it multi? Sorry, I've got to get this right before I say it. Multi-star FWHM focusing. So that has done. So we're going to go out of that by just closing it down here. And we're actually looking at the Silver Sliver Galaxy, which we're just going to take a look at now. What I do is I think I'm going to do a 15-second exposure, and we'll go straight into observe mode and see what we get. So tonight I'm using darks and flats. Wow. People who watch other videos, I don't usually use flats, but tonight, or rather this afternoon, I had time. So I got out my old panel and made a flat, which I just tried out earlier on, and it seems to be working quite well. So we're using the 4.1 beta of SharpCap tonight. And on our first 15-second image, you can already see the Silver Sliver Galaxy. In fact, I have to flip Stellarium because my telescope flips the image in the horizontal. Let's just see what we can see. It seems to be towards 1 a.m. We'll let a couple more subs, 15-second subs come in, and then we're going to start playing with the histogram to see if we can stretch this up a bit more and see a bit more. Now this looks like an edge on Galaxy to me. It's 29.7 million light years away. It's also in the Calder catalogue as well, the Patrick Moore's catalogue, C23 I can see here. You can already see the dust laying. So what I'm going to do, I'm going to balance the colours first, and I leave green where it is, and what I'm going to do is just maybe tweak the red slightly, but actually they seem quite good. Yeah, so what I'm going to do instead is I'm going to bring up the black level. And that's helped the situation. I'm going to bring it up a little bit more actually. And then I'm going to use the mid-level. Now it's a bit noisy, but we're going to stretch it a bit more here. So there we go. So that's really kind of when we do a stretch, we're kind of really only looking at or really enhance that part of the image. It's quite noisy, as you can see, but hopefully that will dim down. I've only done 8 subs so far. Because this is the beta, what I can do is I can press Control 1 and zoom in 100%. If I press Control 0, it goes back out to auto, which is a really nice new feature. I mean, I know Robin puts in lots of new features, but that's probably not the most complicated one. But it is quite a nice feature to have, to be able to zoom in and out 100% and then back to auto. I notice we haven't got the filters on. Let me just put the filter on the brightness and the filter on the FWHM, and that way if any clouds drift across, then it will stop imaging, and also if the atmosphere gets a bit funny, then also it will get rid of that frame as well, which is quite a nice feature. So every time that 15-second comes in, I can see the background image slightly reducing in noise, but it's a very slow process. But what a great image we've got here of this core that's running straight through. There's the central nucleus of this particular galaxy, which is nearly 30 million light years away from us, and extends out. These stars are obviously foreground stars within our own galaxy. No, that's a very nice view. I mean, the other observing session, which I did in December, and the ones I've been out just observing for my own pleasure, has been a bit misty, and the view hasn't been that great. But tonight it seems quite clear. It's still icy out there. It's meant to be warming up over the weekend over here in the UK, but I thought I'd give it a go tonight, and I'm glad I did because that's a lovely image of Electronic Galaxy. We're up to 16 subs now, so it's 4 minutes. The temperature of the camera is 2.7 degrees, and I did the darks when I think it was 3 degrees, so we're still only 0.3, aren't we? So, way, but that's quite an amazing. I don't know if there's any information while it builds up. Let's just go to CDS and see if there's anything. Oh, there's the Sliver Galaxy. It's just come out slightly. Whoops. Oops, if I. So there it is. If we come back down. Doesn't seem to be many. So there must be some reference to it within these papers. But there we go. It's really just nice to look at it. It's just slowly building up. We're up to 5 minutes and 15 seconds now. If I just zoom out again, you can see it in the context. See, obviously, by having a flat, first of all, if you look on the other video, you'll see that I had some lovely dust donuts, which means there's some dust or something on the punt of the optic surface somewhere in the system. And there was one up here and there was one up here. And by doing a flat, it gets rid of that. And also the vignetting at the edges, as you notice, is vastly improved. Where it was quite dark before, now it looks quite even. So it looks nicer. There's no doubt about it. This is a 294, so I'm using an Altair Astro 294C one-shot color camera. And sometimes people seem to have difficulties with the 294. I definitely do when you do flats. But this is the way I did it. I have a light panel, cheap light panel, which I got off Amazon. I did it with I think I did it with 100 gain. It's a monochrome flat, and I didn't do any darks, so no, it's not a flat dark, not a bias dark, and it was quite low millisecond sub I did, and I just did it for 20 frames, and it worked. Sometimes it doesn't work. That's the funny thing. Sometimes it doesn't. And there's lots of stuff on Cloudy Nights about how people do it, and I think all you can do is just do it yourself and find the best way of the right sub exposure to do for your flat, the right brightness level on your panel, or whether you're using a t-shirt and you're aiming at the sky. It seems to be a bit of hit and miss with the 294. I don't know why. But like I said, if you go to Cloudy Nights, there's lots of threads about making flats for 294, and you'll see lots of different ways that people do it. But this one seems to work fairly well. Let's just move the dark a bit darker, and let's stretch the image a little bit more, and let's zoom in again to 100%. Still a lot of noise, but this band of kind of dust within the plane of the actual galaxy seems to be extending out further now as we build up more frames. We've been going for 7 minutes and 45 seconds now. And it's looking quite nice. If I wanted to balance the noise out, I can just bring the mids back slightly. And another thing I do is obviously I can bring in some of the enhancements. So I could put the bilateral filter is on. Oh, that explains a bit. So there you go. It's a bit noisy. If I put my bilateral filter on, it removes it, but I can also then bring my unshut mask on as well. Let's see what that looks like. Hard to tell if there's any enhancement there at all, isn't there, on that one? Let's off with that and off with the noise reduction. Go back into 100%. Maybe put the noise reduction on a bit more on that. Yeah, that's slightly better actually with the noise reduction on. And you can play with these sliders, and it's all personal choice as always. How you stretch is up to you, and what filters you use on it, again, completely up to you. So that's 9 minutes. I think we're going to do an observation. So I'm going to go into AstroPlanner. I'm going to create a new observation for this. I'll say a fantastic edge-on spiral galaxy. The image was a little noisy. The flats seem to be working okay. I should have put calibration there, really, shouldn't I? Okay. A great view of the central dust lane. And once I've done that, I want to do a little snapshot just to record I've seen it. And what I do is it's 10 minutes, which is quite apt. And I say save exactly as seen. And then if I've got a shared folder which is on my laptop outside, and I'll just go and find the Sliver Galaxy. So the name that appears on the banner up here also is used to save the file. Obviously looked at one just now, 600 seconds. So I just drag that across and drop it into AstroPlanner. And what I normally do is I then will take the text file that details all the information about this particular image I've taken, and I put that into the description for that particular attachment in AstroPlanner, and we are done. Where are we? So let's look in Stellarium. We'll reverse that again. I don't know whether to look at M34. Where's M34 next? Because that's a different object. That's let's look at that. That's where?
M34 selected.
Oh, it's called the spiral. Of course it is. A spiral cluster right next door. Let's go into fire mode and slew the 3.6 degrees over to that. I'm going to put this as half a second because we might need to move it when we get there. That looks like a cluster of stars. What I'm going to do is I'm going to take these stars, I'm going to move my telescope up, and then I'm going to bring it back down again because there's a bit of a movement going on there. We're going to try and position the cluster in towards the center. Should we try a slightly less of an exposure? Let's try an 8-second exposure, which means we're going to need an 8-second dark. And let's make M34 the object we're looking at. And that changes the banner, but also changes the name we're saving it under. So we've got an open cluster. It's because it's moderately rich cluster, 50 to 100 stars, 1,533 light years away. Wow, okay, let's off a little bit. Seem to be a bit too far over. Let's get our, leave that as it is. So here we have such a nice cluster of stars, which we will bring down seem to be hard up against the other end of our not sure why we are so far over. We are doing a 8-second exposure. We'll leave it like that for a second because you can alter the black level. Bring histogram onto here. Let me just stretch it a bit more up so we can see those stars. It's called the spiral cluster. Well, it's quite I think it's maybe a galaxy cluster that sorry, galaxy cluster. A cluster of stars that's maybe too big. Sorry, for our field of view. It might be slightly more impressive if we saw it from a distance, if you see what I mean. The field of view of sorry, excuse me. And the field of view of this telescope is 52 arc minutes by 34 arc minutes. We're running at f6.16, which is not the optimal. It should be f6.3, but I backed it off a little bit more just to see. Well, obviously that extends the field of view slightly, but I just wanted to see what it was like, and it's not. I know it's not too bad. Obviously, that it should actually create. It should actually have far more vignetting than it will at f6.3 and so on. But well, I say far more. It should have more, but it seems okay to me. I think that's just a nice galaxy, but not a nice galaxy, a nice star cluster we've seen. So I think we're just going to say that exactly as seen, and we'll observe it as well. So we'll create a new observation. I'm going to say a nice bright cluster. Nice bright cluster of stars, yeah. Same as that, really. If we just do the attachment, we will grab that across. Where are we? M34, the spiral cluster. We'll just grab hold of that picture, whack it into the database, just record what we were doing, description for that attachment. We are done. Let's go to somewhere else. Now I love this object M33, the Triangulum Galaxy. It's a huge face-on spiral. It's 18.2 degrees from where we are now. So let's set that in the planner and also sync it with Stellarium.
M33 selected.
And as you see, it's very large. It doesn't fit in my field of view, but we're going to look at the central part of it. In the last video, when I discussed my EAA setup, we were also looking at M31, which is an even larger galaxy. We're not moving, so I'm just going to do a 15-second exposure this time. So I need a 15-second dark. And let's go straight into observe mode and see what we've got. And there it is. Straight away you can see here's the central core, here are the arms coming off of it. Let's just move up our blues. And move up our reds. And let's get our black level more this way. I mean, I'm not 100% sure why the histogram is so far to the left. It wasn't earlier on. It seems to be getting more and more to the left. But as we bring it up, you can see on your image now. Oh, I'm going to make it a bit brighter. So you can quite happily make out now these arms coming out of it. There's definitely one very big one there. Then there's a small one here, another one up here. There's also some bright spots around as well. Let's zoom in 100%. So do you see we have these other objects, these bright knots of light in here as well as these specklings of like star clusters that you have in Andromeda as well. It's quite an impressive sight. Let's drag it up a bit more. And the great thing about this is in the last video I showed how I use AstroPlanner to see globular clusters in the galaxy. So I use AstroPlanner and SharpCap together to produce a catalogue, which then SharpCap can then show you the position of certain objects within it. And I have one for this as well. So if I just do bring up the deep sky annotation, should I say? It's not slightly on. So the crosses are showing the different type of objects that are there, but they're not exactly over. So I think I need to do another plate solve. And if I press nearby, hopefully the next frame it will take and plate solve it. And there you go. So now it's much better. So we're at 100% zoom. And these little crosses are showing different things. So for example, this very bright area is NGC 604, and it's an H2 region. So most probably a star forming region, and that's the same one as you can see here in Stellarium. And we've got NGC 595 over here, another H2 region, NGC 592, IC 131, and IC 137. But then you'll also see, for example, this little here. In fact, if we zoom in a bit more, you'll see it. And this is M3333, and it's a globular cluster in or orbiting around M33, which is 2.7 million light years away. Here's another one, M3331, that's magnitude 16.5. And we'll move down. We've got globular cluster M3329 and a couple more over here. Let's go back to 100%. So these tools are very useful, and I showed you how to do it in the previous video. I did my EAA setup, and we looked at M31 and its globular clusters among a couple of other objects as well. But you can do the same kind of thing here. It's really easy to identify the different types of objects that are here. Let's get rid of that a second and bring back up AstroPlanner. And let's take it out to auto so we can see the full frame of view. And that's coming on quite nicely. So we've got 17 subs so far. We're doing 15-second subs. Remember, we're using darks and lights tonight. Darks and flats tonight. Let's see if we can really stretch this. That's quite amazing, isn't it? That is quite, that's 19 subs so far. And this is the beauty of EAA, to be able to see this rich structure within this galaxy, 2.7 million light years away. I mean, Andromeda obviously is angled to us slightly, so we see it more of kind of the edge as well. But this is like full on, you can actually kind of see inside, see the workings of the galaxy as if you're above and looking down And you can see all these H2 regions where stars are forming. We can see the globular clusters, which are rotating around it, orbiting around it, just as globular clusters orbit around our galaxy and around M31. And all this with a 14-year-old CPC-800 with a camera on it. So the color, the temperature, the camera's temperature currently is 2.7 degrees. Now the camera isn't cooled, it only has a fan in there to drag outside air in. So we know it must be below zero if it's at 2.7 degrees. It'll be interesting if there's any ice on it, which over the past week or so when I've been out to observe, especially if it's been slightly misty, you get ice on it. In fact, one night I went out and I thought, oh no, it's snowing, and all it was the ice crystals suspended in the mist. I mean, it was a beautiful sight in the torchlight to see all this kind of glitter, but not so good when I looked at the telescope and found it again. It was covered in a thin layer of ice. Isn't that amazing, that image? It's all out to here as well, these scatterings of brighter areas within it, clusters of stars which look bluish, so maybe young stars forming out here, and then it gets more distinct as we come in through the arm. But there's these bits out all the way over here, and this another little arm out here going off the field of view, little puffs, wisps of star clusters and so on. Again, up here, there's just so much to look at in M33. It's just absolutely amazing. Well, that's 7 minutes and 15 seconds. So that's, sorry, 7 minutes, 30 seconds, and it's 30 subs so far. The green seems to have now taken over, so we can color balance again a bit more. Where's the blue gone? Oh, there it is. Sometimes it's quite hard to see the blue against the black. It would be nice if you could invert that. Maybe that's another option we could be looking at. Or shall we stretch it a bit more? I mean, it's a personal choice. Wow. Wow, that's a great galaxy. Now, I've already done an observation, can't get my words out tonight, an observation of this earlier on. It says an amazing sight, the spiral arms and bright, cool, great detail. I think what I'll do is I'll just take exactly a scene and I'll add another attachment in with that image. We'll take it off the shed. Drive M33. Oh, there's two. Hold on. There. We're going to grab that, put it into there, and we'll grab the settings, the camera settings, put it into the description, and we'll come out of there. So that was fantastic. Oh, it just kind of satellite goes straight across just to finish it off. Let's go into fine mode. We'll set it to ½ a second. I need to change the script to make it slightly different. Now, let's go to the Fiddlehead Galaxy. Let me just look at that. So the Fiddlehead Galaxy, so NGC 772 and NGC 770. Let's do that. Let me just move myself a second, actually. So this is the field of view as built into our AstroPlanner, so I can see what I'm going to see. So I'm going to go to, let's make that the actual object we're going to observe, and let's sync to it in Stellarium.
NGC 772 selected.
Fiddlehead Galaxy. Okay, we're going to slew 13 degrees to that. Let's go. Let's stretch the image as we go so we can see the stars whiz by. Now, NGC 772 and NGC 770 have actually interacted, and we're going to see if we can see that. Or they're thought to have interacted. I can see something here. Let's move it up a bit. Okay, I think we're going to go for a 15-second sub. Let's go into observe mode and see what we can see. So let's see for the first sub to come in and see if we were kind of central on what we thought. Oh, wow. Why have we got such a large FWHM? Are we moving still? Let's see if we are. I think we are. Let's pause that a second, clear it, pause it. Let's come back into fine mode again. I'm going to half a second. Stretch the image. Okay, what I'm going to do is I'm going to take it up and then I'm going to bring it back down again to make sure that there's no let's see if that was the problem. Sometimes my telescope has that kind of, it drifts up for a while before stabilizing, especially on the kind of eastern side of the meridian. So we're going to observe mode again. Let's just see if that solved our problem of the very high FWHM. Did it? Let's have a look. Yes. So that's what was causing it. It was still drifting upwards. Let's do an auto stretch just to, oh, auto stretch maybe rather than the colors. There we go. And we bring our reds up to match our green. And our blues need to come up a little bit. There we go. There we have the Fiddlehead Galaxy. So what we're going to do is let's bring our black levels all the way over to here. And bring up our mids quite aggressively. We're still having problems color balancing this. So we can see the bright central core of the Fiddlehead Galaxy here, and we can see it here. And we can see this long arm coming out here. And this NGC 770 is right here. So if I just zoom in 100, we've only done 9 subs so far. So this is a distance of 130 million light years. So this is far more distant than M33 we just looked at, which is only 2.7. Its diameter is around 200,000 light years. And this NGC, this other galaxy, it says it's surrounded by quite a few dwarf elliptical galaxies. We might take a look at the deep space annotation in a minute and see if there are any around in this area. But this galaxy here, NGC 770, is thought to be the likely cause of why this long spiral arm has been drawn out of the galaxy. Obviously, during a close approach or some way, it's some way gravitationally affected that particular spiral arm and given it this kind of elongated feature. So there's NGC 770 and there's NGC 772, the Fiddlehead Galaxy. We've done 13 subs so far. We're zoomed at 100%. We have stretched this out quite substantially. There's something else here which is not marked in the planetarium software. What we might do in that case is if we do deep space annotation, and we would do a solve on the next frame and see if there's anything around here. Oh, no deep sky catalogs found. HIP 8832 is just out of view. Is that HIP 8832? Yeah. Oh, it says there's nothing there. Oh, I wonder if I've turned off NGC. I'm going to do PGC while we're at it. Objects in view. I'll have to reload. There we go. Yes, it is in fact surrounded by loads of other galaxies. So there's NGC 770. There's another little galaxy here, PGC 212884. That little kind of cloud we saw was PGC 1577957, which is a magnitude 17.4. There's another little 17.4 here, a 17.7. There's a much brighter one, a 15.2, which is UGC 1445 over here. Let's zoom in. So you see this was the kind of stuff we saw. There's one, two, that's NGC 70. There's another one down here. Drag it. There's some over there. There was another one over here, wasn't there? The UGC. Let's drag that out the way. There you go. UGC 1445 is magnitude 15.2, and there seems to be a whole cluster around over here of little galaxies. So let's just zoom back in again, get rid of the deep space annotation. Let's pull the black levels up a little bit more. Let's balance off the, I've come too far, I think. Let's balance some of the noise off by taking the mids down a bit more. So this arm, this spiral arm is now quite obvious. This arm here is fairly obvious, as you see right across here. It's starting to see that there is something around this galaxy as well. As you see here, there's some arms wrapped around as if maybe NGC 770 is pulling it. And there's something over here almost as if it's been pulled out all the way around following NGC 770 as it causes the Fiddlehead Galaxy to have a few major wobbles. So we're at 6 minutes 30 seconds, and we've still got quite a bit of noise here. They come back out. Let's bring up AstroPlanner again. Let's do an observation of these two. So let's say the extended spiral arm is very obvious. galaxy is surrounded by fainter neighbours and NGC, was it 770, is bright and obvious below the main galaxy. And we'll just take a picture, save a scene at 8 minutes 15 seconds. We're going to attachments, and we're going to see something else. So we need to find, oh, that's not what I had in mind. Let's, must have closed the folder. There we go. We are at, what was it? NGC 772. Grab that across. Grab this across. Put it in the description for that particular attachment. Come back out there and see where else we can go. Patrick Starfish cluster. Well, that's surely a good place to end. Let's set it and let's find out where it is. While I'm doing that, I'll just come out of there. Oh, did it not go? Hold on.
NGC 1245 selected.
Right, let's see where we are. So we're in Perseus and we're above our house, or my house, and we're in the east. Well, that seems a quite interesting cluster, isn't it? Let's it's 32.1 degrees slew, but let's have a little slew over to there. See how far off we are as we come. Oh, here we come quite quickly. We're at an altitude of 77 degrees. There it is. And just like we did before, what we're going to do is we're going to take it up and bring it back down to its central. We'll just do a 15-second observation because it's all set up for it to happen. Let's do that. Let's observe. So what have we got? So the Patrick Starfish cluster, also known as NGC 1245. So it's discovered by William Herschel, 11th of December. Oh, that's good, this month. But back in 1786. The cluster is nearly 1 billion years old. Wow. NGC 1245 has about 200 members, the brightest of which is 12th magnitude. Oh, wow, look at that cluster there. The cluster is estimated to be 27 light years across. That's quite something, isn't it? It's almost got the same light pattern. I'm just going to bring down the noise a bit. Well, it's a nice little cluster. Why is it called Patrick the Starfish cluster? Some of these names are always a bit strange. I do like the fact it's called Patrick the Starfish cluster, though. I take it SpongeBob. I don't want to... I'm sure it's yeah, SpongeBob, Patrick, favourite. There's a little crescent of stars here. Zoom in. Do you see this little like a horseshoe of stars? Very nice. These little strings of starlights coming out. Increase the colour. Do we see? Yeah, we see some blue stars and then some orange and redder stars in the image. Some very blue stars here. Within AstroPlanner, if I go to the field of view, it also, when it's the, what kind of, are we up for star labels? 8. Let's bring up the thing up to 10. When it does it, it brings up the color that it puts the text in is the color of the star. So there's lots of blue stars here. And the area of the sky it's in, it's quite high up, as we can see here. Well, it's 77.9 degrees up. And it's to the east, which is not the best side because my house is in the way there, but it's quite high. Because it's quite high, we can see it quite happily. So you see the blue stars that are around it, beautiful colours, and then you've got the more orange stars and the yellow stars. There's some orange stars here and here and over here, and then you've got these big blue stars here as well. Let's go out to see it. You can see it's set. I don't know if Patrick, let's have a look if it's anywhere near the Milky Way or actually in the Milky Way. It's in the Milky Way as it would be because it's in Perseus, of course. Wow. Oh, that's a nice star cluster. There's just so many things to see with EAA. It's fantastic. So tonight we've seen M33, which is one of my personal favourites. That flat on the edge, that's completely face on spiral, was amazing with all the detail in it. We saw the edge on Sliver Galaxy as well, which was fantastic. The Fiddlehead Galaxy, that was magnitude 10.3, so that was actually the lowest magnitude object that we looked at tonight, and it didn't shine, but we could definitely make out that elongated spiral arm, and we obviously read about NGC 770 being the cause of that. M34 was okay, but I think it was too big for our actual telescope's point of view, and I think the Patrick, the Starfish cluster NGC 1245 is a far better object for our type of telescope. And I love the colours of the stars, to see the colours of the stars, the structure in galaxies. Fantastic. EAA, amazing. I think you should all put an Astro camera on your wish list for Christmas. Might be too late now though. Fantastic. Anyway, thank you very much for joining. I hope you enjoyed our little trip around the sky tonight. If you want to check out my setup, see the previous video, and have fun and have a great Christmas. Thank you for watching. Bye-bye.